All right, this is the Algebra 1, new Unit 8, Lesson 1 video over polynomials. And the main focus of this lesson is going to be just some terminology that you need to know around polynomials. And so we're just going to go through each section and talk through the different concepts that you need to be aware of. So the first thing is what kind of is a polynomial, or what are the different parts of what we're talking about? Well, what we're talking about is an expression that has a constant, a variable, and or any product of those things. So multiplication of constants and variables. So what you see here, these are what we call monomials. So another way of referring to that is a term. Okay, so you've heard some of this terminology before previously in Algebra 1, but we're just kind of getting some of this down. So a term is any sort of product, multiplication of numbers and variables with exponents. So you can see, as just as some examples here, we have 4x squared, there's a constant, there's a variable with an exponent. 8 is a term, it's just 8. There isn't any variable there, but that's okay. It just is still itself a term. Okay, so these are all examples of monomials. Even something as lengthy as this, it's still a product. It's multiplication of a constant, 2 times x times y and z have exponents, but that's okay. Now there are some things that you cannot have when you're dealing with a term of a monomial or anything above that. Okay, first thing, the exponent has to be whole numbers. So you see here we have x to the third, y to the third, y to the third, z squared, x squared. Those are all whole numbers in the exponent. You can't have negative numbers. You can't have fractional numbers in the exponent. The exponents have to be positive. They have to be whole numbers. There can be no variables in the denominator. That's what you see here and here. You can't have an x or a y in the denominator of a fraction. The variable itself cannot be an exponent. You can't have 3 to the x power. The x or the y has to be on the main part of the expression. And lastly, the monomial cannot be a sum or difference of terms. In other words, it's not adding up a bunch of things. That's what a polynomial is. That's what a binomial is. A monomial, a term, is just one unit made up of multiplication. All right, so these are kind of those key factors right there. Now, when we begin to add together monomials, when we begin to add together these terms or subtract, we start to build binomial, bi meaning 2, trinomial meaning 3, and then anything above that is called a polynomial. So take a look at this table here and just notice we have monomials. These are, again, just individual terms. Binomials, 2 plus 4, 3x minus 2y, x plus 3, 4x minus 7. These are binomials because they're made up of two terms that are being added or subtracted together. And as we go up, we get 3 terms, and then we get 4 terms. And then we can continue going. 4 or more is going to be a polynomial. So this kind of information about the number of terms, you need to know that. Monomial means 1. Polynomial means 4 or more. Trinomial is 3, and so on. Now, so that's kind of one big concept, what a term is, and then what monomial, binomial, trinomial, polynomial. Then we need to discuss what we refer to when we talk about the degree of something. So the degree of a polynomial or the degree of a term is its highest exponent number that it contains. The highest exponent number that it contains. Now, x by itself, you need to remember that anytime we have a number that is just by itself, we assume that there is a 1 there. So make sure you remember that. So in these examples, just to run through them really quickly, this term, x, is a monomial, and it has a degree of 1 because the highest exponent is a 1, x to the first. Now, with x squared, we now have 2 because the highest exponent is a 2. Now, when we begin to go where we have multiple terms, we see that we have the sum of those. So the degree of this is 1, x to the first, plus 3, y to the third, plus 2, z squared. So this has a degree of 6 because there are 6 in the 6 exponent numbers in that. This is kind of a weird one, but because x to the 0 is here, it means the highest is 0. And then here we have 3 plus 2 plus 4 is 9. Disregard this. Numbers, constant terms, don't get counted. You only count the variables and the exponents that they have. Never count constant terms. So this is 3 plus 2 plus 4 is 9. Now, that's how you tell the degree of an individual term or a monomial. Now, how do I determine the degree of a polynomial? Well, it's really simple. It's whatever the biggest term is. In other words, the highest degree term is the degree for the entire polynomial. So looking at this example, this term has a degree of 2 because x squared. This term has a degree of 4 because it's 1 plus 2 plus 1. This has a degree of 3, and we don't count that one, even though they put it there as a 0. So because this term has a degree of 4, that means it's the biggest one, and it is the degree of the entire polynomial. You don't add those numbers up, you just pick the highest one. All right, so that's how you determine the degree of a polynomial. Now, one of the last kind of concepts you need to have is what we call the coefficients. And remember that a coefficient is referring to the number in front of a variable. So here, 2 is the coefficient of x squared, 3 is the coefficient of x. But when they say leading coefficient, we are referring to the very first coefficient of the entire thing. So in this, the leading coefficient is going to be 2 because it's the first coefficient, okay? And the leading coefficient is always when it's written in what we call standard form. Notice here, there's 2 different ways of writing the same polynomial. Well, this is the appropriate way because here the degrees of the terms go down. You always want to do degrees from highest to lowest. So then the leading coefficient here would be this 2y to the third because when we arrange it appropriately in standard form, it's going to have the leading term. Last kind of concept is just the names for particular kinds of polynomials of different degrees. We already talked about what a constant is. A constant is when there is no degree, when there's no variables, it's just a constant. Linear functions are ones where there's a highest degree of 1. We've already dealt with linear functions in this class. We've also dealt with quadratic functions. Quadratic functions are when the degree is 2, meaning there are terms that have a total of 2 degrees. When there are 3, it's called cubic. And then from there, we just name it based on the number. So 4th degree, 5th degree, 27th degree, whatever it is, the highest one is what we choose. So that's just a lot of vocabulary that you kind of need to have down. I would definitely make note of these things. I'll also try to put some summaries in the notes myself. We're not going to talk about adding, subtracting polynomials right now. We're going to come back to that because I don't think there are any questions about it here. So let's look at what's in the problem itself. Or in the section itself. Identify the expression. Okay, you need to identify this as a monomial, trinomial, polynomial, or binomial. So how many terms are there? You need to look up at the table above. That's what you do for 1, 2, 3, and 4. Then you identify the degree. You need to find which term has the most exponent numbers, the highest number of exponent numbers. That is the one that is the degree of the entire polynomial. That's number 5, that's number 6. number 7, number 8. So for 5 through 8, what's the degree of the polynomial? Which term has the highest number? That's the number you use. Remember, terms are each individual part. Like here, this is a term, this is a term, this is a term. 3 terms. So go through each term. Which one has the highest degree? Okay, so I'm going to pause the video so I can come back and talk to you about numbers 9 and 10.